All right, we're doing 9.3.3 Algebra 1, multiplying binomials, okay? So I'm going to have the first 7 questions. I'm probably not going to do all 7, but what I am going to do for all of these problems, I'm going to do it 2 different ways. There is a FOIL method, and then there's a box method. I am a personal fan of the box method. I learned it actually as a teacher. I don't think I remember learning it as a student. And once I saw it, I was like, this is great. It's a great visual way, but the FOIL method was what I used for my entire math career, and it is quite effective and works. So I'm going to use both of them. All right, so I'm going to do question 1. Jump right into it. So this is question 1. We have FOIL, and then we have box. See if I can keep this organized. Oh, what happened? What did I do? All right, so question 1. I want to write it out as x minus 4, 2x plus 5. All right, so FOIL method. So it's first, so I need to multiply x times 2x. So in each binomial, right, so this is a binomial by a binomial, I'm multiplying the first term in each. That's the f. And then there's outer. I'm going to take the very outside ones, and I multiply them. And then I'm going to take the inner, which is the innermost, multiply them. And I bet you, I'm going to try to do the FOIL method and like really sell it. But I'm such a big fan of the box, so I'm probably not going to be as energetic about it. All right, so what this will end up looking like is we have x times 2x. And then we're going to have x times 5. And then we're going to have negative 4 times 2x. Ooh, I'm going to run out of room. And then I'm going to have negative 4 times 5. So I multiplied everything in the first equation by everything in the second equation. End up with this. So x times x is 2x squared. X times 5 is going to be 5x. Negative 4 times 2x is going to be negative 8x. And this is going to be negative 20. All right. The last step is we always have to combine like terms. All right. So we have 2x terms here, so I have to combine them. So I have 2x squared minus 3x minus 20. So what I did is I multiplied my first terms of each binomial, so the x and the 2x. I multiplied the outer one, so the x and the 5. And then I had to multiply the inner ones, the closest together, negative 4 and 2x. And then the last ones of each binomial, which is negative 4 and 5. And I got my answer. So I kind of color-coded it. Now, if I was to do a box method, all right, so if I was to do a box method, is I have x and negative 4, so I'm going to write x and negative 4. I'm going to kind of separate them. Then I have 2x and 5, so the second binomial I'm going to write vertically. And then I'm going to multiply, or I'm going to create a box around it. All right, so I created this box, and now I'm going to multiply. So I'll do it in the blue. So I have 2x and x. This is going to be 2x squared. So everywhere I intersect is there. I have x and 5 is 5x. And I'm trying to use the same colors. Negative 4 and 2x, right? They intersect here. Negative 8x. And then I have 5 and negative 4, which is negative 20. And notice how the colors all kind of match up. All right, so now I just set it up here and I just multiply. And a cool thing about the box is diagonally, most times, not always, but most times, these will be like terms. And I can just combine them. Boom. All right. Now, we got the same answer, 2 different ways. I don't care which way you use. It's going to be your choice. I just want to show you both of them. Again, I'm a personal fan of the box, but I didn't learn it until a couple years ago. So I obviously use FOIL my entire life. All right. Let's do number 3. So let's try this again. So we have 2x plus 3, and then x plus 1. All right, so I'm going to go there, 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 and there. So we're going to have 2x times x, and then I'm going to have 2x times 1, that's the outer, and then we're going to have 3 times x, and then we're going to have 3 times 1. Well, that's going to be 3x, 2x, and 2x squared. Again, I have like terms there in the middle. I combine them, and I get my answer, 2x squared plus 5x plus 3. Let's do it with the box method then. All right, it kind of changed my box a little bit. We'll work with it. We have x times 2x. That's going to be 2x. Okay, I don't want this. Never mind. All right, let's try this again. I don't want that. Okay. All right. There we go. Give me an ugly box. There we go. Sorry. Automatic stuff. All right, now here's try it again. 2x times x is 2x squared. Now we're going to do 3 times x. Right? Just intersecting boxes here. 2x and 1. 3 and 1. And then right there, diagonally, are like terms. And I get 2x squared plus 5x plus 3. Again, same answer. Gotta love it. Just 2 different methods to do it. Whatever you're comfortable with, you may use. Does not bother me. Whatever you like, I'm just going to show you both ways. All right, let's do, we'll do question 5. So we have x squared plus 2, 5x plus 1. And as always, if you have any questions, need more detail, just always ask. So first, outer, I definitely gonna need more than one row on this one. All right, cool. And then I'm going to do the math. X squared times 5, I have to do it all. So this is going to be 5x cubed. And then we have x squared times 1 is going to be x squared. Then we have 2 times 5x is going to be 10x. And then we have plus 2, 2 times 1. Cool. That's what I got. Let's try the box. We have x squared, 2, 5x, 1. Better to keep the uglier box. All right, so we got blue, which is going to be 5x cubed. All right, we got orange, which is going to be x squared times 1. 5x and 2 is going to be 10x. Red is 2 times 1. And now we have a scenario where our diagonally are not like terms. All right, so I said usually that is that way, but sometimes it's not. And one way to know when it's not going to happen is if you look at your original problem over here. I guess I should get a different color. Look at your original problem over here. they are not the same. This goes from a square term to a constant, and the other polynomial is an x to the first power and a constant. So they're different in terms of terms, so they were never going to have like terms diagonally. Make sure you're in descending order. And there you go. All right, let's go ahead and I'll do 2 more. Let's do 6 first. Now 6, the first thing I'm going to do with 6 is this is 2x squared plus 1 squared. That just means we have this. Don't let that exponent confuse you. That just means you have 2 of them. So there's what you're multiplying. So we have 2x plus 1, 2x plus 1. Let's do our FOIL first. Outer. Inner. And then last. Just doing multiplication now. And then we're looking for like terms right there. We have them. And now we can rewrite the equation. 4x squared plus 4x plus 1. All right, let's try the box method. All right, I'm going to get rid of the colors. I'm just going to go all at 1. All right, so I have 2x and 2x right here. That's 4x squared. I have 2x and 1. That's 2x, right? I'm multiplying. 2x and 1, 2x. 1 and 1 is 1. Diagonally, I have like terms. 4x squared plus 4x plus 1. Final answer, done. All right, we'll do one more. We'll do number 4. It's going to be more unique, I think. All right, now I'm going to do this one with less colors as well. All right. So we do x times 3x. X times 3x is 3x squared. X times 2 is 2x. Negative 5 times 3x is negative 15x. Notice how I'm skipping a step, which is fine. You can always go back to the other examples for the full steps. Negative 5 times 2 is negative 10. Combine my like terms here. 3x squared minus 13x minus 10. Shebang. Oh man, what the heck is that? Three x and x is 3x squared. 3x and negative 5 is negative 15. X and 2 is 2x. 2 and negative 5 is negative 10. Diagonals like terms. And just like that, bada bing.